Okay, hello everybody, and welcome back to React Native London. This is the March edition. So some of you may not know, but we're doing a little sort of beta test of a hybrid event. Now, what that means is we've got some wonderful people in the office, also watching alongside people online. And then more on that later for next month. So before we get started, a bit about the sponsor and host this month. So we've got Fiodo. So I work at Fiodo as well. So what do? We are a lean product engineering team. So we often help and deliver startup MVPs. We scale up projects, we rescue, we do long-term stuff. And we mainly work with React Native, TypeScript, Node.js, AWS, serverless, Next.js, and Django. So yeah, that's a bit about Fiodo. Now, we are hiring. As everyone else is, we want full stack devs, agile coaches, technical leads, and project directors. So if you are interested in joining, definitely give any of us a message or email, join us at fiodo.co.uk. Cool. So one thing I want to talk about before we get into today's meetup is next week. So next month, we have the April meetup, and this is going to be our sort of first official in-person event. So we're coming back from COVID with the remote events. We're going back to being an in-person event, but not to worry for you remote guys, it's going to be a hybrid. So again, that just means we're going to have like the in-person event with all the people joining, and we'll also have the online stream so everybody can stay if they're not available to go. Awesome. So let's get into today's two talks. Bit of an introduction. So first off the bat, we have Alex Davis. So Alex is going to be talking about ClojureScript and React Native, the what, why, and how. So in this talk, he's going to be covering the basics of ClojureScript, why you might want to use it, and show how you can build React Native apps with it. Should be awesome. And then after that, we have one of Fiodo's finest, Angus Findlay. He'll be doing a talk on React navigation. So navigating your users to paradise. So a bit about React navigation. It's an essential library for routing in React Native apps. In this talk, he's going to give an introduction about the library, the common pitfalls, and how to use TypeScript to improve the developer experience. So two really interesting talks today. So without further ado, we'll get into the first talk. Yep.
All right. Hello, everyone. My name's Alex, and this is my talk on ClojureScript and React Native. So a bit about me, I work for a company called Juxt. And interesting fact about Juxt is that the name comes from one of the standard functions in the Clojure library. And as you might expect from a company who names themselves after a programming language function, we mainly do Clojure. We do a lot of consulting work for startups to big investment banks, but it's all in Clojure. And we've done React Native apps as well as web apps, backend things, all sorts of stuff. So Clojure, maybe you've heard of it, maybe you haven't, probably you haven't. It's still a pretty niche thing, but it's a functional programming language. And I'm sure many of you have heard of functional programming because JavaScript has gone a lot onto the functional programming route. Really, like if you look at Clojure, you'll see a lot of map and reduce and filter, and that's a lot like JavaScript. Also like JavaScript, Clojure is a dynamic language. You don't have a big compile time. You can evaluate functions as the program is running. And Clojure runs on the front end, the back end, on mobile apps. It can be hosted on all sorts of different environments, like JavaScript as well. Clojure is a well-designed language. I think the creator spent a long time thinking about it before he wrote it. Not really like JavaScript, that one. And Clojure is a Lisp. So Lisp is a very old type of programming language dating back to 1958, I think. It stands for list processing, which is a strange way of doing an acronym, but it basically means that everything is treated like a list. And I'll get into these things in a bit. But first, I just want to have a brief overview of syntax. So this is an expression that I'm sure you're all quite familiar with, the good old console log. And we have a function, so console.log in this case. We have our arguments. So we've got two here separated by a comma, hello, and this object of A1 and B2. And to transform this into a Clojure syntax, all you really need to do is move the first parentheses here to the front, and then in Clojure it's called print, or print, and that's it. Then the two arguments, instead of being separated by a comma, we have no commas in Clojure, because we like to not make loads of typos, or at least that's what I do when I'm typing JavaScript. And things are instead are just separated by white space. And you'll also notice that the colon that in JavaScript separates a key and a value has been moved. This is because there's no separation with colons. It could be, the number one and another one next to it with no colons at all. The colon A here is just a keyword, which is a concept in Clojure that defines a type of symbol. But there's a few special things, but I won't get into it. But basically, this is how the syntax works. You have a list, so surrounded by parentheses. The first item in the list is the function, and everything else is an argument to that function. So hopefully that makes a bit more sense, but I'll go over a quick example with something that I'm sure everyone knows, FizzBuzz. So FizzBuzz, if you Google it with JavaScript, you get something like this. This is probably what most people would come up with in an interview. And you're looping over 100 times. If it's divisible by 15, you're printing FizzBuzz, and 3, it's fizz, and 5, it's buzz, and so on. In Clojure, it would look something like this. So kind of a lot going on there. Let me just unpack this quickly. So I wonder if I can get my cursor to show here. Okay. So in JavaScript, I think the most interesting thing here is that we're actually defining a variable I equals 1 here, and we're then mutating it. So we're changing the value of this variable every time we go over the loop. So we're actually increasing it. And then when it gets to this condition, it will stop. Whereas in Clojure, although it kind of looks the same, you have a for, and you have your variable here, and you have your sequence of numbers. There's no mutation going on here. For is actually a macro, which is a crazy Lisp way of defining new syntax. And the for macro actually compiles into some recursion that's in a functional style. So no mutation goes on here. And this range is just a function that takes a start number and an end number and produces a list of the numbers between these two values. So this would evaluate to a list of 1 to 100. And then we would change number here, which is just a binding rather than an actual variable, to each of those numbers while we're executing the body. Then we have this cond_p function, which is actually another macro. It takes a predicate, which is a function that returns true or false. In this case, we've called it multiple of. In real life, we might extract this out into a real function. This is actually just an anonymous function, even though it has a name. And this predicate will be evaluated against each of these cases. So if n, our number, is a multiple of 15, we'll do FizzBuzz. If it's a 5, we'll do buzz, and 3 is fizz. So I think the main reason why I think this is a bit nicer than the JavaScript solution is just because all of the logic is contained in one function rather than have it be scattered across. And you can definitely do it in the same way in JavaScript. There's no reason why you couldn't have this contained. But I think that one of the things about Clojure is that it encourages you to contain it by giving you things like cond p. So let me go a bit more into those things that I mentioned earlier. So first off, functional programming, as I said, JavaScript has been doing this a lot recently, and React as well. The move from class components to function components has led to a big push in the functional direction. And basically, Clojure and ClojureScript will treat data structures as immutable objects by default. So maybe in the JavaScript world, you've heard of like immutable JS or Immer, these sort of libraries. They take a normal JavaScript object and they have some changes to it so that when you do, an object dot something equals whatever, you're not actually changing that. And if you access it in somewhere else, it's not going to change. Instead, you return a new copy of the thing that you're changing. And ClojureScript does all of this by default. So there's no importing something, there's no learning like a different thing. That's just how everything works. However, sometimes you need to mutate things. The world is not immutable. And in those cases, Clojure has a very nice method of mutating things when you need to. So there's other functional languages like Haskell that you may have heard of. That's a lot better when you want to make a program that's provable and mathematically correct. ClojureScript is more pragmatic than that. So dynamic, that you'll hear Clojure people talk a lot about REPL-driven development, and I'll go into that in a minute in a demo, and also this modifying the code base while it's running. And there's some cool debugging stuff that you can do with a dynamic language, but JavaScript is very dynamic as well, so not much difference there. As I said, you can run Clojure on a lot of different hosts. So officially, there's the JVM. If you're in a big enterprise, a lot of the time you'll have JVM everywhere. And if you don't want to write Java, which not many people do, Clojure is a pretty good alternative. But also JavaScript, you can either run it raw on top of a JavaScript VM like V8, or more commonly, you'll use a tool like Google's Clojure compiler to transform it into standard JavaScript before you run it. And there's also the CLR if you like Windows. There's also some community options for running Clojure. There's SCI, the small Clojure interpreter, which can read sort of strings of Clojure formatted syntax and evaluate them instantly, sort of like Python and Ruby. This is great if you want a script, or if you want a Lambda function that needs to have a really, really quick startup time, because JVM Clojure has got some limitations there. There's also some other Clojure-inspired spin-off libraries that go to Julia or Lua or other scripting languages like that. So interop is obviously a mandatory thing when you have a hosted language like this. You'll have the platform like JavaScript in the case of ClojureScript, and you want to be able to access JavaScript data structures. You want to be able to use JavaScript libraries. You don't want to have to give up all of that and rewrite all of the NPM modules that are out there just to work with ClojureScript. So I think there's a great way of doing interop. I'll cover this more in my demo. And you don't need libraries to interop, but you can if you want to make things a bit easier. You can also import JavaScript files directly. And again, I'll show in a bit a project. I have a React Native project where I've got some TypeScript files and I just import them into my ClojureScript files, and they just work together. And you can do it the other way around too. You can define a Clojure function and you can use that from within your JavaScript. A bit about the design. The core Clojure library is small and can be learned quickly, but it has pretty much everything you need in it. Like there really aren't that many utility functions or utility libraries out there. Whereas in JavaScript, a lot of people will reach for Lodash or, Immer.js, or there's a whole bunch of different libraries because the core of JavaScript is really quite limited in what it does. And that's not really JavaScript's fault, it's because of its history, but still. Many things in the modern JavaScript world have actually been inspired by Clojure. So Redux, if you've used that, that actually was directly inspired by a ClojureScript library called Reframe. And JSX was pretty much inspired by Hiccup, which comes from Clojure, a few other things. And there's been very few changes. So I'm sure everyone in the JavaScript community is used to things changing under them every year, having to learn new things. Clojure is like the total opposite of that. You can get a Clojure project that was written 10 years ago, run it on the latest version, and pretty much nothing will have changed. You can run code that you wrote last month on a Clojure version from like, a few years ago. And unless you're using some of the very new and niche features, it will still work fine. This can like have a disadvantage. I mean, the JavaScript community moves really fast and comes up with cool stuff all the time. And Clojure is a lot slower. So, pros and cons there. And things are almost never surprising. So because everything has a very logical, like thought out design, a function that works on a list will also work on a vector or an array or other type of list structures. And things will usually produce the result you expect them to once you've learned the few core rules. Whereas in JavaScript, as I'm sure many of you have seen, the well-known Watt talk, things are not entirely sane. Although actually JavaScript has improved a lot. Like if you try this in Node now, you'll get the same thing for some of these things, but they've improved the language. And I think that comes back to JavaScript moves fast. It improves things a lot, but it also changes things a lot. So Lisp, a bit on that. Yeah, I think I've formatted my slides in Lisp here, so you can see that. Really though, I think people get freaked out by all the parentheses and that sort of turns them off Clojure. But once you get used to it, once you have learned like the tools in your editor for controlling where the parentheses are, and I'll demo this in a bit, then it really is like a great thing. And you feel a lot slower going back to a C-like language like JavaScript. So that's what ClojureScript is and about Clojure. But why would you actually use it? I mean, after all, there are problems with using ClojureScript, like using any sort of compile to JS language. You've got an extra build step, you've got extra tooling to worry about. And especially when you have something like React Native, where you already have sort of this very, very complicated process of changing your JavaScript into native code that runs on a device. Why would you add like another step on top of that? There are definitely reasons why you wouldn't, and I'm not suggesting that everyone rushes out, deletes their code base and changes it for Clojure, but there are some good reasons. If you have complex business logic, I think this is really where Clojure excels because of the immutable data structures and the sane core library. You can really do like a lot of very complicated, large projects without getting into a total spaghetti nightmare. The REPL workflow, which I'll demo, is I think a pretty good reason. If your backend is running Clojure, so same reason why people I think really like node.js is because you can use the same language on the front end and back end. But sometimes you need the JVM, you need like the monitoring, maybe you're in a bank and that's all that there is. And having the same language from front and back is a good reason. You kind of have to get your hands a bit dirty with Clojure tools. JavaScript tools generally are like very well polished and very beginner friendly. Clojure, not so much, although it has improved a lot recently. Or you just want to learn something new. I think anyone can learn a lot about programming in general from picking up a bit of Clojure. So even if you don't actually ever use it, I think it's a good thing to learn. Right, so I've talked a lot, but now is the time for a demo, and we will see how much of this actually works. So I have on the left here my editor. I'm using Emacs, but there's good Clojure support now for VS Code and IntelliJ and all the major editors. And I've got a project open here. This is actually my React Native project. I've got a blog post where I go more in detail about how I set up the project and how you get connected, which I'll link at the end. But it's a basic routine app. You can add routines as a form and different components here. You can click through to them. You can run different things. And okay, the React Native web doesn't scale properly, but it was a bit hard to share my phone, so I'm just doing it here for demo purposes. But I think you can get the idea about the app. Now, this is running in Clojure, but a lot of the files that render the views are actually in TypeScript. So if I look at my project layout, I can see here that I have a bunch of Clojure files in Clojure, but if I go back, I've got this stories directory, and I've got all of my view components in TypeScript. So if I look at this, this is all standard TypeScript. And this is possible because ClojureScript just compiles to JavaScript and TypeScript compiles to JavaScript. So you can set up the build tools to just put them in the same place and then let the Metro bundler take over from there and the rest of the React Native process. So the tool that compiles the ClojureScript is called Shadow CLJS that I'm using. And you get this sort of dashboard with it when you have it connected. So this is actually connected to my editor as well. So I can actually run these things and I can get the answers out by evaluating these little forms in my editor. I can also inspect the runtime. So I can see all of like the different things that have been created and the objects that have been defined in the namespaces that I have, which is pretty cool. You can like tap things. So there's this tap function that if I run it, then you can see it, it's sort of like intercepting the value as it's flowing through the code and logging it here, where I can go in and I can inspect it. And here earlier, I've sort of tapped a JavaScript object. So I think this is the React navigation thing that gets passed around. So this is pretty cool. And this is possible, again, because Clojure is so dynamic. Something else that you can do actually is if I go to my views thing here and find this like handle select routine function, which is called every time I select a routine, I can actually like define the navigation object in line. And then when I click something, this will actually have intercepted that value and it's like bound it to a local variable that I can then evaluate. And what I can then do is I can, in my code, type in like med10, which I think is one of my routines, and run this dispatch function, which is actually navigated in my app live, like as I'm just in the code. So if I wanted to test out what happens if I try navigating to a number which shouldn't be valid, you'll see I just get a white screen. Maybe I want to add like an error checking case for this. So it's really useful to be able to evaluate things in the code, test stuff out, define stuff in line and see what it is at this point in time without having to resort to console logging or saving the file and waiting for the whole reloading process to work. Because that's another thing that this avoids, is that I don't need to save anything ever, really. So I could write a alert here and I can evaluate this, and I haven't saved the file. I haven't reloaded anything. Metro hasn't needed to recompile, but I'm getting my alert when I click a routine now because I've added it and I've evaluated that while the program is running. So that's basically a quick overview of the app. I have like a few little demo things here to show some more of like how Clojure actually works. So this looks a bit complicated, but this also looks complicated. This is basically like one of the things that people struggle with when they start is the prefix notation. So instead of in JavaScript, I would do 1+1 or whatever it might be. In Clojure, as I said earlier, the function comes first, and in this case, plus is a function, I can actually jump to the definition of plus. And this is like in Clojure core, the core library. And I can see how it's defined and how it takes, any number of arguments, and it uses reduce to do them together. And then that means that if I added any number of things as arguments to the plus function, it's actually going to sort of automatically reduce them all together and sum them all up. But because I have wrapped everything in brackets, when I want to nest things together, you kind of get into a situation like this, where I'm doing 1 plus whatever this evaluates to, and then this is 3 minus 2 minus whatever this evaluates to, and this gets quite hard to read. So there's like a little cheat that you can do where this arrow macro, which will evaluate to this, but it's a bit more readable because I know here that I have 4 and I'm dividing it by 2, and then I'm timesing 4 and 5, and I'm minusing 3 and 2. And I can evaluate this. I could delete this and see all of these different things, what they come up to. And because I've got like these structural editing commands as well, if I delete line here, it's not going to delete that end bracket because it knows that this is important. So it won't actually let me delete this. So there's some, interesting stuff around how you move around the editor and how easy it is. Another thing is that Clojure has a lot of these predicates built in. So anything that ends in a question mark, it's just a convention. It's not actually syntax, but this is a function that will return true or false given an input. So even and 3 is going to return false. But if I do even and 4, that's going to return true. So pretty simple function. We can actually jump in again, have a look. We can see it's got some error checking, but it's using this bit and then it's getting complicated. But in JavaScript, I don't even know if you can do this. I don't know if you can just jump into the definition of a function, especially not with something like plus, because it's not even really a function. It's kind of a syntax that's interpreted by the VM. So I think that's a really cool part about Clojure, is that everything literally is a function or a data structure. And that makes things very easy to reason with. So another thing here is this is a macro when, and it's like if, but it's only got one return statement. And everything in Clojure is returned when you have the last item in a list. So in this case, when even 4 is going to return hello, when odd 4 is going to return nil. That's another thing, is that getting stuff out of objects. If I have an object like this, I have A and 2, and I want to get A, that's obviously going to return 2. But if I try B, that's going to return nil, which is the same as null. Whereas in JavaScript, that would blow up, and I'd have to remember to put question marks everywhere. So another pet peeve about JavaScript there. You can have this let block, which is a way of sort of doing locally scoped variables. So here I'm like binding A to 2, I'm binding B to 4, and then I'm adding them together. You can define variables. So this is basically the same as doing const numbers equals and an array of these numbers. There's this for macro, which I sort of went over earlier in the FizzBuzz example. But one thing I didn't mention is that you can have these like extra syntax sugars, like this when key, which is only going to loop when the number is odd. So if I do this, it will only return 1, 3, and 5 from my list of numbers up here. If I deleted that, then it's going to return all of them. I can sum things up. I could do reduce as you would in JavaScript. And because plus is a function, I can just put plus straight there. I don't need to wrap it in an anonymous function or anything. I can also apply, which is kind of like doing plus and then spreading out this array. So apply will apply plus to every number in here. And that comes up with the same thing as reduce, but they are slightly different. I can define a function like this. Here's the name of the function. Here's the list of arguments it takes. And here's the body of the function. And then I can use my function here to find out, in 5 human years, there'll be 45,005 JavaScript frameworks. And I can also do that to find out, how many dog years there are in human years. So many useful things like that. And finally, a bit of more of a complex example. Here I have an array of objects. So remember, there's no commas, which makes things like this a bit easier, although maybe harder to read if you're used to commas. But this is just an array of objects. And in this case, all of the objects have the same keys. But I can show some details about this array. So I could do count on my data, and I can see there's 5 different things on there. I can do first to get the first one out. I could do type, and that's a persistent vector is what it's called. But there's some useful utility functions in the core of Clojure. So if I wanted to sort this, I guess there's a sort in JavaScript, but in Clojure you've got a sort by. So I could sort this by the danger level, and this will come up with this. To make this a bit easier to read when you have a REPL evaluation, there's an inspector tool. So I could get that up here actually with this inspect, and that's going to show me the result of my evaluation in this sort of visualization that I can look at. I can also group by stuff. So if I wanted to group by the type, for example, that's going to come up with a object with 2 keys, and that's the types, and it's sort of grouped the things and indexed them by the type key. There's a bunch more stuff that I could get into. There's, frequencies, for example, which tells me how many of each unique type that I have in my list. And there's a bunch more like helpful utility functions that you really sort of when you start to learn them, you realize how much is missing from the core of JavaScript. But I think that is basically it. I think I've got one more slide just showing some a recap. So in conclusion, I guess, ClojureScript is great in my totally unbiased opinion. I think you should try it. I mean, I'm not going to say it's the ideal solution for every project. There's definitely places where I pick JavaScript or TypeScript to do things. But especially if you really are fed up with JavaScript, ClojureScript can be quite a bit of a break from all of the craziness. There are some tooling difficulties though. It's sort of like JavaScript a few years ago. JavaScript obviously has really good tools nowadays, especially like things like Next.js. When I've tried them out, they've been really streamlined. They do a lot of stuff. But on the other hand, Clojure tooling tends to be a lot simpler. It's not trying to do so much magic. So you kind of can actually go into the tooling and figure out how it's working. Whereas, I find that pretty difficult in JavaScript. There's lots of big companies that use Clojure, so it's got a lot of support. Recently, it was bought, or the company Cognitect that are behind Clojure was bought by Nubank for I don't know how many billion, but it was a big acquisition. And there's all sorts of very large organizations that are using it. React Native, also there's a lot of companies that are using ClojureScript for a React Native app. There's like Pitch, who does collaborative presentation software. There's a big open source crypto wallet, which you can go on GitHub. You can look at their massive React Native app that they have. It's all in ClojureScript. If, as I said, you're having issues with JavaScript and you want a break, then it solves a lot of problems there. It's easy to try out. Actually, I had there's a tool called NBB, which someone's made, and it's actually just a JavaScript NPM module. So you can do npx NBB, and it will bring up a ClojureScript interpreted REPL, and the Shadow COGS tool as well that I showed the console of is really nice. And compared to a few years ago, the ClojureScript environment has definitely gotten a lot better. And I think many things can be learned from how it's laid out, how the core language has sort of been structured, and how the different data structures work with each other. I think there's a lot of stuff to learn there. And I think a lot of stuff has been learned from it. And you can see its influence in a lot of different languages. And we've got a bunch of resources here. If you are interested in learning a bit more, I'd recommend clicking on some of these links. I'm sure the slides will go somewhere. And that's it from me. So I guess, do I take questions now?
Wow, Alex, thank you for such a great talk. To be honest, I have never even known about ClojureScript or Clojure at all. And this was a big eye-opener in terms of like getting functional stuff done. And it just like compiles the JavaScript, which is awesome. So it's very like utilizing. So I have a couple of questions before we go to YouTube or Angus over in the main room. So one of the questions I wanted to ask is like, how did you find ClojureScript? How did you get into it? What's the sort of background for that?
Yeah, great question. I have a very strange story there because most people that I speak to, they did Java for 15 years and they were sort of got to the point where they were like considering throwing themselves off their office block, but then found Clojure and, it's a lot more sane. But I actually, it was my first job that I got straight out of university. I didn't even really do a computer science degree. So I just sort of applied to a bunch of programming jobs and happened to get one from a company that only does Clojure. So that's how I got into it. It's a bit unusual, but yeah.
Yeah, that's awesome. That's a really interesting story. So like, how popular would you say ClojureScript is these days? Do you think it's going up and up, getting more and more use, like in production as environments sort of thing, or what's the state?
Yeah, it's another good question. I think if you look, so ClojureScript has actually been around for, I think, pretty much exactly 10 years now. I think it was 2012 that it was released. And for about 5 years or so, it didn't really get that much attention. It was missing a lot of stuff. Like there was no sort of hot code reloading. It was very temperamental with the tooling. But then about 5 years ago, there's some big libraries that came out to really help with that, some big talks. And then it sort of had like a big boost in use. And that's actually about when I joined Juxt and started doing it. I remember one of my first projects was sort of doing this React Native app. And there was a lot of like hairy things, but overall it was pretty cool. However, like recently, like the last few years, especially, I think it's just gotten a lot stabler. So even the JavaScript ecosystem has like quietened down in the number of things that it's released. And yeah, like 5 years ago, I remember Expo would break every 6 months and you'd have to rewrite all of your navigation stuff for it to work. Nowadays, like that stuff has settled down and Clojure it thrives when it's on top of something stable because it wants to be stable too. I think there's like another company I didn't mention, Vouch. They've sort of based their whole company on ClojureScript and they only make this sort of mobile app platform for doing digital car keys. And actually one of the people, the CTO, I think, of Vouch is this guy, David Nolan, and he's one of like the core contributors to the ClojureScript language. And he's got like some great talks where he's brought a bunch of React JavaScript developers on and they have like the same split like that I was inspired by him actually to do, where you have your view components in TypeScript and your business logic in ClojureScript. And I think there's a few other examples, like I know Walmart and Apple and some like pretty big companies are using it. So yeah, cool. I can't say exactly what the graph looks like, but it seems like there's quite a lot, and we always have lots of work at Juxt. So
yeah, no, awesome. That sort of leads on to like a question I wanted to ask from the YouTube sort of chat. So Elvan asks, is it difficult to find a job where Clojure is in use? I think you've sort of half mentioned it there, but is it a niche market? How easy is it to get a job, basically?
Yeah, it's definitely a niche market. There's definitely less jobs if you're just counting number of positions in Clojure than there are in JavaScript, but it is very like in demand. So hiring, we're always hiring basically, but usually we don't hire Clojure developers. We hire, people out of university or who have sort of done a bit of Clojure on the side or just have an interest in it, and then we train them up. Like that's the general hiring strategy we have, because there are more Clojure positions than there are people out there who know Clojure. And I think that's because if you already know Clojure and you've already done it for some years, then as soon as you like start looking for a job, you just find one, because there's so many people who want Clojure developers, even though it is like a small niche market.
Sure. No, that makes sense. I had one final question for me. So I've done a bit of functional programming, and it was mostly like Haskell. And I found the learning curve quite hard, just because of like the different sort of frame of mind, like how you think about like solving problems. Does that happen in ClojureScript as well? Do you think like it's quite a hard learning curve?
Yeah, definitely, especially if you come from a language like Java or C or something where mutating state is just the only way of doing things, really. And I know actually like a lot of languages, Kotlin and Java and these sort of things have been moving more towards a functional style, and JavaScript as well. As I mentioned, Clojure is probably more functional than all of those, although it's not really a competition. But I think it's quite good in the way that it encourages you by the design of the language to do things in a functional way. And although it is always going to be a difficult learning curve to get around the fact that you can't just do I+1 in a loop, and that's not how you really do things. You use map and you use these sort of helper functions around this sort of immutable recursion. But Clojure is designed so that you don't really need to think about that. I mean, I know in Haskell, as soon as you start thinking about like monads, at least that makes my head hurt. So I don't think Clojure is quite that problem, though also it's not trying to do what Haskell is trying to do, so they're kind of separate.
Yeah, no, speaking of monads, it's just made my head hurt straight away. So you're 100% right with that. We've got one more question from the YouTube. Elvan again asking, are there any big applications that use Clojure in production in React Native sort of thing? Which I think is a good question.
Yeah, so the one I mentioned, Pitch, I think pitch.com, I think it's pretty big. It's actually quite a cool tool for building presentations. I know their mobile app is all ClojureScript. There's Vouch, as I mentioned, they do these sort of cryptographically secure car keys that you can open your car from your phone. There's, I forget the name of it, a big like cryptocurrency wallet has got their whole platform built in ClojureScript on React Native. Probably awesome. I'm missing some, but there are definitely a few.
Awesome, no, it's good to hear. Angus, is there any questions from the main room?
No, I feel like we've covered a lot of ground there, so
yeah, that's
really great. Thanks so much, Alex. It was really cool to hear about you interacting with the code while it was running. I think that stuff is like mind-blowingly cool, and like I'd love to see some of that stuff in JavaScript. Yeah,
100%. But I think it's just time, Angus, that we move on to our second talk, which is just to remind everyone, is React navigation, navigating your way through life, which is a great talk. Really interested in this, excited. It's gonna be fun. So yeah, stay tuned.
Great. Hi, everyone. Today, my talk's about React navigation, which is basically how it's such a core fundamental library to React Native, and it's kind of like the links, the browser of React Native. So, I think it's really like an essential thing to learn. I don't know how many people already used it, how many people have never used it before. I think there's something that's taught for everyone, so hopefully everyone gets something out of it. Cool. Yeah, my name's Angus. I work for Theodo. I'm sure Callum's already said enough about them. I'm really interested in functional programming. So I loved Alex's talk. And native apps and web development. So there's my chat if you're interested. So React navigation. The problem this library is trying to solve is that in React Native we don't have the browser, right? The browser is completely gone, right? We don't have any of the stuff that comes with it. Not just talking about the toolbars. I'm talking about like the back button, the URL bar, links, everything. Like it's not something you get. So what do we have to do instead? We have to recreate all of this interaction ourselves. So this is kind of where React navigation comes in. So here you can see we've got a series of links that I followed. I've gone on a new tab, I've gone to Google, I've gone to BBC, like this is kind of a stack. So kind of the point I'm trying to get to here is that the browser has a stack. It's like the back and forward buttons, and then this is a classic data structure for computer science. Whenever you visit a link, it goes put on the stack, and whenever you go back, you're popping off the stack and going to the previous thing. React navigation has this built in. I think you're probably used to one if you've ever used an app where you can swipe left and right. It's pretty cool built in, and React navigation kind of gives you all this stuff for free. So if you ever thought like, my app would look pretty cool if it had this like nice swiping animation, React navigation basically gives you that one completely for free. I'll show you some code about how you get this stack navigation in your app. You start off with a navigation container, everything, you only ever need one and everything goes in it. So you create a stack navigator like this, you add you add the navigation component, and then you add the screens like this. So you give them all a name. The name is just a string that you use. It's kind of like the link or like the URL you give your page. And the component is basically a React component that will render that in full screen on your app when you're on that page. Here we have like basically the link. In this case, we just got button. And when you press the button, you're going to go to, you're going to call navigate, which is a React navigation function that will go to that string. So here we use the use navigation hook. This is kind of the new style of writing React navigation that I suggest you use. And you can just use this use navigation function from any component in your React Native project. We also have navigation.go back, which is really useful, and we'll play the animation for you. I think that's one of the strong points of React navigation is that all the animations are like built in, really easy to use, and give you like professional looking apps, like basically for free. We also, some sort of question that comes up quite a lot, and a question I often had is like, what's the difference between using navigate and push? So there's two functions here, here where we use go back and navigate. There's also another one called push. Push is like what the browser does. We're always adding links to the stack. It doesn't matter if you're revisiting an old page, you're always going to be adding another link and you have to go back. Whereas like navigate, if you've already been there, it will just jump all the way back to that page. So it's kind of quicker like that. And it kind of keeps the navigation stack small, keeps it like simple. So what else don't we get from the browser? We don't get links, right? No URLs, and no URLs need no URL parameters, right? URL parameters, being like google.com/search ? And then, this thing you're searching for, right? But React navigation is sort of this too. When you navigate to a page, you just give it like a JavaScript object, just like this. It tells you, use the item ID here, and then you can have any parameters you want. I think this is kind of quite a simple and nice way of doing things, but it can lead you to like down to some kind of like bad practice. So it's quite important that you do things the right way, and we'll talk about that in a bit. Here's how you use the root. It's the same kind of way you use navigation. You just use root, and then you can just use .params.caption and get all of your props out like that. Here's some things you should use it for. User ID. So you say you've got a profile, you want to go to like profile with this username or this user ID. That's really good. Say you wanted to you have a page, but you have different ways of looking at it. So you can sort by latest, sort by trending, sort by the oldest posts, things like that. If you're doing pagination, so say you had a list of a list of items going back in time, or here we've got a chat feed and you want to see messages from before a certain timestamp. This is really cool. This is a good use. And if you were going to like pre-fill inputs on a form, so say maybe you were taking a link from the web, and this is another thing React Navigation can do that we'll get into later, is that if you take a link from the web, you can like turn it into a navigation call that will have like pre-filled parameters for you in a form, which is really sick. There are some negative things as well. Here's what you shouldn't do is like put all your state in a URL parameter. This isn't a good idea. You should be storing your state somewhere else so that it's kind of more controlled. You don't want to end up with like redundant things and like losing track of data. As an example of a kind of more complicated stack navigator, you can think about Twitter. So if you ever used Twitter before, you have like 3 or 4 different pages. A lot of apps have this now, Instagram as well, where you have like a search at the bottom bar. You have like search, home, your messages tab, all these different tabs, and they will actually all have their own stacks. It's kind of something we've internalized, but it's something we don't really think too much about how it's implemented, right? So like if you're on Instagram, you can basically go to any part of the app from any of those 5 different screens, right? Home, search, profile, messages, and they all have their own individual stacks. So you can they're kind of just like having tabs on your browser. And how would you implement that in React Native, React Navigation? This is a nested navigator, right? I would be kind of careful with using a nested navigator because this is kind of where things start to get harder and harder. But if you want this kind of premium user experience that people are used to with like the big name apps, it's something. Or if you work with a client, you end up asking for this eventually. So here, what you do is you have one root navigator. This is the tab navigator, and this will give you that. If you use React Navigation, you can use React Navigation bottom tabs, which will give you all the features that you need for this for free. And then you can put stack navigators within that tab navigator. And basically you can keep duplicates. So if you always want to get to a profile from these screens, you can share those components across. And then sometimes you might want unique ones from inside those too. Here's an example of how you do it. So here's the tab navigator that has feed, search, and messages. And then in those components, feed, search, and messages, you're going to want to define, again, a stack navigator. So inside the tab, you have the stacks, as an example. With these nested navigators come some nested navigation calls, which can get pretty intense too. So say we've got this is kind of like what we were looking at earlier, where you have a root tab navigator. And if you wanted to go all the way from the timeline of the home screen all the way up to search to see the search results, you kind of have to tell React to like bubble the events up the tree and then go back down. So how you do this is use navigation.navigate with a screen as another parameter, and then React Navigation will handle it from there. So this is how you do that. It's just not as easy as giving it the results string, because it has to go up the navigation tree and then back down. Not just like, if you were doing a web app where you just give it a link. Just something to keep in mind. And if you had a really nested hierarchy here, we've got like a settings within a sound, within media, you'd end up with these really nasty navigation calls. And I think this is just mainly here as a slide to say, don't do this. Don't nest your navigators really hard. They're not meant to be a way to group components. They're meant to be a way to like give some specific functionality for your app. It's something that the users will see. It's not an implementation thing. So yeah, don't do it. The key takeaway here. Yeah, deeply nested hierarchies are bad. They can give you performance issues. You can end up with, like, I think it's almost like it's like a code smell that you're going to produce a confusing UX, right? Like if you have tabs inside, inside stacks, inside other tabs, it's like the user will be baffled when they use your app. I think one level is deep enough. And your code is going to get, as I showed you earlier, completely baffling. So as I was saying, there is an alternative. You can use group. This is kind of built in to React Navigation. So if you want to have that semantic grouping of screens, and maybe because you want to reuse them in different apps and export them as like a kind of a reusable component, you can use group. So yeah, this is moving on to the next part. This is this picture of global warming. This is here because in React navigation, one thing that I often see people don't understand is that the screens don't really unmount. It's not like a website where you go to another page and like all the components are going to disappear. In React navigation, when you add things to the stack, you've got kind of still got everything underneath. And this can cause some really strange behavior if you don't get the right mental model. So use effects are completely out the window, right? This isn't going to work. Instead, you're going to have to use focus effect, which is a kind of React navigation's version. So focusing a screen is when you go to the screen, when your phone opens it, or when the animation slides back. Whereas use effect is actually when the component mounts. If you know anything about React, that's kind of basically the first time it appears on the screen. Here's an example of a use focus effect. One strange thing is that you need to put it inside the use focus effect. You put a use callback. So it's kind of like two levels of hooks. You also need to return any cleanup code in that use callback so that you don't end up like subscribing to loads of events and producing really confusing and hard to debug errors. But this is it. So say if you wanted to subscribe to an API, every time the screen loads afresh, this is how you do it. Some more React navigation stuff, and I think this is really the selling point for React navigation, is that there's so many complicated and hard to implement on your own features that you just get for free with all the animations. So here's modals, right? You know, kind of like a sliding up window. Apps use these all the time. These are so easy to use. You just take a screen and you give it the presentation modal option. Nothing more to it than that. Here's a draw, right? I didn't even know this is what this kind of component is called, but it's like you slide over from the side. All those gestures and all that stuff, super easy to do. All you have to do is give it the draw navigator. It's kind of like the tab navigator. You just have to give it that create new draw navigator, and it's just like a sub library. So the way that React navigation works is that you have the main libraries and then you have like smaller packages that give you more features as you go. But this is all very straightforward when you go to download it. So one thing that after I was working with React navigation for a while, I kind of thought like, when I'm navigating to a route, I'm saying, I'll click on a button and I want to go to the profile screen. And I'm just giving it a string, right? It's just like a URL, I give it a string. And in my IDE, I'm typing it and I'm just like, oh, well, I could be typing anything here. I don't remember if it's called profile or user profile or profile page. If you're a TypeScript fan, you're probably thinking, is this even pipe safe? Shouldn't I be using some other kind of thing? Maybe a global file that has all the names of all the routes, which I've seen on some projects. But no, the better idea is now with the new version of React navigation is to type it, with TypeScript, which can get quite confusing, but I think it can be really worth the payoff. If you can create like a good, useful type that will help you to understand the nature of your navigation, especially if you're using nested navigators, that can really tell your developers you're working with how to get from screen A to screen B. This is my little disclaimer here. TypeScript is a little bit sketchy around the edges. So when you see some of these types, you might be thinking like, this looks really weird. There's so many angle brackets. It's like indented in the page. I think this is kind of a sign that we're trying to type something that's very strange. Typing the concept of a nested navigator, a custom navigator can be quite weird. And just because you've created these types, it doesn't mean that you're necessarily completely safe from like making a mistake. It's quite easy to subvert this, or like, have a page that's not rendered because you're not logged in or something like this, and trying to express whether the user's logged in a type is like insane. So I don't think we'll be doing that for another few years. So if we think back, right, we think back to our previous app where we had our home, our profile, and our feed. How would we create a type for this? So the first thing we do is we create this type called the param list. So it's usually just the name of the stack. So this is root stack, and it's the root stack param list. So we've got home, profile, and feed. Those are the keys, and those are the names of the pages. And then after the colon, so the kind of the value of the type is whatever the parameters are. So here we've got home is undefined because you just go there. There's no parameters needed. And profile takes an ID, and feed takes like a sort, right? Or it takes undefined because you can also go there and it has a default. So once you have your stack param list, you can use that as the generic type for the stack navigator when you're creating your root stack. And now that's typed. And then when you're thinking back to your home screen, when you're actually using the navigation component, and you're using your use navigation, you can pass in a nav prop, which is another type we have to create, which just looks like this. It's just a stack navigation prop, and we pass in that prop, that type we created earlier, along with the string profile, and that it represents the fact that we're on the profile screen. So the motivation for this is that when you're on a screen, you can't really navigate to yourself, so the type is slightly different. That's why you have to refer to it here. So this is like now completely typed. So there's a couple of types you have to make. You have to make your nav prop over here, and you have to make your root stack param list over here. But then the reward here is that when you type in that navigation.navigate home, that string will appear in your editor, and if you type it wrong, TypeScript will throw an error. Cool. So these nested navigators I was talking about earlier, where you have tabs inside stacks, and you're swiping and you're tabbing around. How do you actually manage to type them? Well, it gets even more confusing, to bear with. But say we had this nested navigator set up that we saw a few slides ago. You type your navigation prop with the composite screen props, which takes two screen props and it combines them as if they're nested together. The first one is the top level one, and the one below that is the one above that in the tree. And like now this is typed fully, and you type it the same way when you use your use navigation. Cool.
Thank you, Angus. That was a brilliant talk. I use React Navigation every day on my project at the moment, but I learned a lot from this talk. Particularly the stuff about like the typing, so like the composite screen props and the stack navigation prop. I don't think we're using that at the moment, and we're fully updated on React Navigation, so that's something I definitely want to implement. So again, thank you. And also I didn't really know about like the grouping stuff. With like the use focus effect that you showcased, like obviously with a use effect, you'll have like a dependency array so that when it changes, the use effect will be called again. Does that happen with a use focus effect? Do you also provide a dependency array?
So when you use focus effect, you actually provide a use callback hook into that, and that's where your dependency arrays goes. So the use focus effect itself doesn't have a callback array. And this can get quite confusing, so it's quite easy to get caught out if you don't use that use callback inside the use focus effect, because your page, if your use focus effect changes something in your page will then re-render, your use focus effect will rerun, and you'll be stuck in an infinite loop. So make sure you remember that use callback. Yeah. So
and then going back to the groupings, I don't think I fully understood like the use case. Is it only when you want to copy? You say you've made some screens and you want to like group them together and then copy them to a separate project, that group is like a good use case? Or can you briefly go over that?
Yeah, so the motivation behind the groupings is basically, you find some developers when they want to just say, okay, here's all my screens that are to do with the user profile, or here's all my screens that are setting screens. You find the developers, they could be putting them in a nested navigator just because they think, well, these things are the same and they go together, right? But like, that's not what you should be doing, because that's going to add a whole level of complexity to your navigation. Really what you should be doing is just doing a group, and it's kind of like a React fragment, if you've ever seen that before. It just says this code is related, but it has no like runtime overhead. It's just purely like a semantic grouping.
I see. So say you had like 4 settings pages, you wouldn't put them into like a stack for settings. You'd put them into a group, and then technically they're siblings of the rest of the stack. Awesome.
Yeah, exactly. Yeah,
exactly.
exactly.
I need to use that as well then. I'm not sure we're doing that either. I think that's really interesting. Yeah, Is there any questions from the audience over there, Angus?
Questions, guys? Right, cool. Okay, great.
Any questions?
Oh yeah, sure. So we got one question in real life.
Sorry. How are you handling deep links in nested cases?
Yeah, so in nested cases, deep links can be quite complicated in general. Definitely something that apps, I kind of think I kind of left them out of this presentation just because they can be quite complex. But kind of the joke with deep links is that, like, eventually every app is going to want them. If you're watching and you don't know what a deep link is, it's like when you send, say you had an app and someone shares a link to your app or something within the app, it's easy to just open the app. You actually want to open the app to the page. So you basically have to create your own app, your schema that will allow you to link deep inside the app. So for nested navigators, I don't think it's good to reflect the nested structure of your links by nesting your app further and further. I'm quite like a nesting anti-advocate. So I think the best thing to do is to just handle it like in a custom way, where either you kind of match the linking schema to how flat your app is, or you kind of you map a deeply nested link to like flatly nested React Native. Thank you. Yeah, good question. Thanks very much.
Yeah, we have one comment in the YouTube. Elvan, again, it's not really a question, but a statement that I think is worth mentioning. Just like he said, he cries every day with React Native navigation, which I definitely feel his pain sometimes.
Yeah.
Yeah. Alex Davis, did you have any questions you wanted to ask at all?
Yeah, actually, I guess I'm interested in what you think the overall TypeScript story is with I don't know if you can compare it to like web React, and you said it was a bit nasty. How nasty is nasty? Do you think it's still worth using it? Like on web, I would use it on every project, but is it the same on mobile?
Yeah, I would still really recommend typing your React navigation projects, and nowadays we don't really even have a choice with React navigation. I think if you're typing your React navigation project and you think it's simple or it's too easy, you're probably not doing it right. It's always the trade-off with typing is that the better your types, the harder they are to read. The more you can narrow them down, the more complicated they are to understand. I was kind of joking a little bit about the TypeScript story. I think it's almost good because it helps you understand the complexity you're creating in your application when you try and type these things. And me making this presentation actually came out of me trying to type those nested navigators, thinking, oh my God, am I doing everything wrong? Which I was.
Awesome. Yeah. If no one else has any questions, we can wrap it up there, I think. So sort of before we go, I thought it's worth mentioning what's in store for next month. So as I said at the start of the talk, next month is going full in-person hybrid mode. So we're going to be advertising that a lot starting tomorrow, sort of thing. We've got two fantastic speakers. So we've got an ex-Twitch employee and CEO of a recently funded Y Combinator startup coming to talk. He's going to be doing a talk remotely. And then we also have a BAM employee, so from France, a guy named, I'll mess up his name because it's French, but bear with me, Alexandre Moreau. He's coming to talk about performance in React Native. He's been doing some really awesome work in terms of standardizing how we can, profile performance in React Native. It's a bit of a empty spot at the moment, and he's been doing some really fantastic work, and he's going to come and talk about that. So it's going to be really, really interesting April talks. So yeah, anyone remote or anyone in person, definitely stay tuned for that and get tickets once we start the meetup for that. Awesome. Yeah. So again, thank you, Angus, and thank you, Alex. Brilliant talks, and I'll see you soon.
Thanks very much, Callum.
Thank you all.